Okay, so we're going to finish up the cone problem. I already said that cones are special. And by special, I just mean they're a little bit more difficult. There's more going on in cones. You have to figure out more information. It's not all just given to you in the problem. So yesterday, we did the Twiggy. We filled it out. And I want to go ahead and look at the cone. I know we did this yesterday, but I want to look at it again. The original cone, like the cone container, is 10 feet tall, and the radius was 3 feet. All right. Now, when we look at our water, do we know the height of the water?
Yeah.
Yeah, that's 3. Do we know the radius of the water? It's not given, but I'm thinking I'm going to need it eventually. Can we find it? Yes. These two cones are similar. All right. So what we're going to do is use a proportion to solve for r. All right. So I'm going to start with this r over h ratio. The radius divided by the height. That proportion, okay, for the the big cone is going to be 3 over 10. What is it for the little cone that represents the water? Yeah, I'm going to go ahead and just use r over 3. So what does that make r equal to? When you cross multiply and divide. 0.9, and you can use 9/10, or you can use 0.9. Really does not matter to me. So 0.9 feet. So really, this kind of can go up to my when statement. Because when the height is 3 feet, the radius is 0.9 feet. Okay? And that's like what's happening at the instant I want to know. This 10 over 3 business, I'm really not going to use in the problem because all that was just given so that I could find r, given h. All right, so there might be some more things we need to find, but let's just go ahead and work the problem, and we'll just find things as they come up. So we always, after we do Twiggy, and here I did kind of a little bit more to fill in, we start with the equation. Okay, so this is write an expression involving the variable of the rate to be determined. Okay, so what we're going to do here is we're trying to find dH over dt. I'm actually going to skip this one, all right, for just a minute. That's really what I'm trying to say. All right, let's look at our volume. So I'm kind of just deviating a little bit from the directions here, and I'm going to approach this more like how we did already. Because you're not going to have these questions when you're doing the problem. You're going to have to come up with it on your own. So I'm going to get you to answer some of these. So we have our v equals 1/3 pi r squared h. Let's go ahead and take the derivative with respect to time. Always, always you take your derivative with respect to time. Okay, so on the left-hand side, it's easy because I have my dv over dt. On the right-hand side, it's a little bit more complicated because look at this. I have 1/3 pi r squared h. Which rule am I going to have to use to take this derivative? I mean, I have to use chain rule no matter what. Chain rule is just embedded all over the place. But look at this. 1/3 pi r squared times h. Product rule. Okay? And the 1/3 pi could actually go with either variable. I'm just going to keep it with the r squared since it's first. And so remember with product rule, you're going to take the derivative of the first term. That's going to give me 2/3 pi r. And since I took the derivative of r, remember I got to write dr over dt. Then h. Plus. So what I wrote so far was the derivative of the first term times the second term. Now we just need to switch it. So I'm going to just write the first term. I'm just going to review product rule a little bit here. Never hurts. And what comes after this? What's the derivative of h? 1 times dr. What did we take the derivative of? dH over dt. Okay, so let's look at what we have now. Before this, we could just plug everything in, solve for dH over dt, because remember, this was our find. We're looking for dH over dt. So do we know dV over dt?
Yeah.
Yeah. What was it? It was -2. Why was it -2?
Oh,
Because the water's dripping out. So the volume is decreasing. That means the rate of change of volume has to be negative because the volume is decreasing. All right.
Did you put H before the dH over dt?
I took the derivative of H, and so that was like a 1. I didn't write the 1, but that's really what's going there. Okay, so then I have 2/3 pi. What's R again? We just found it. 0.9. Okay, dr over dt. Do we know that? Is it written up in our givens or our wins? Okay, if that had been given to us, this problem, we'd be almost done with it. Okay, so it's not. So do I have anything else on my paper? Maybe an expression, an equation that has to do with R and maybe H, because remember that's what I'm trying to find in the end. The volume, but I've already taken derivative of the volume formula. That's how I got into this mess. So what else? Maybe something we just did today. Look at this. R over H. I'm going to rewrite this right here. R over H always equals 3 over 10. It doesn't mean the radius is always 3 and the height's 10. But that proportion will hold up no matter what. I could have used 0.9 and 3 here. It's the same value when you divide those two numbers, so it doesn't really matter. Okay. I could go ahead and take the derivative of both sides now, but what would I have to do with this business? R over H. I would have, or R divided by H, I would have to use quotient rule. Let's see if we can get out of that. Do you see a way that maybe we could just get R by itself?
Multiply it.
Yeah, multiply it. Okay, now, and we saw this yesterday where we had to kind of go and do a side problem. Now I'm going to take the derivative of both sides. The reason I'm doing this is because I need to know what is dr over dt. I don't know what it is. So I'm hoping this is going to tell me. So if I take the derivative of both sides of this equation, we're going to get dr over dt equals, what is the derivative of 3/10 h? 3/10 dh over dt. Okay, so I don't have a number for dr over dt, but I do have an expression that I'm going to now plug in. And it's going to work because I don't know dh over dt, but I am looking to find it. And so I'm at least getting closer to my answer. Okay, so I'm going to plug that in right here. And are y'all okay if I use 0.3 here?
Yes.
All right. It just takes up a little bit less space. All right, what was our height again in our problem? Yes, I do. Thank you, Rebecca. I do. I'm so concerned I'm running out of space. That's okay. I'll just write plus down here and we'll be all right. So then H, what was H in our problem? 3. Okay, plus. So I'm going to just go ahead and go into this next line. So I have now 1/3 pi. We just said R was 0.9, so 0.9 squared. And then dH over dt again. All right, now how many dH's over dt's do I have? I have 2. What do we normally do when we have 2 and we want to make it become 1? Yeah, I need to factor it out. I actually can get out of it this time because everything beside dH over dt is a number. It's not its own expression, it's just a number. So there's some number times dH over dt plus some other number times dH over dt. Those are like terms. It may not be obvious right now, but let's simplify. So this is where I said using your calculator is going to help. And I know the simplification is not required all the time, but it will make what you need to do next easier if you do it. And if you get a calculator, it's not that hard at all. You just type in 2/3 times pi times 0.9 times 0.3 times 3. And your answer should then be something pi. So go ahead and type that in. And if you get a fraction, that's fine. Most of the time, these are not going to turn out nice numbers. That's why you have a calculator. What'd you get? 0.54. Did anybody else get a fraction? So we got a decimal because we typed in decimals, right? If we had been typing in 9/10 or 3/10, we would get then a fraction, okay? It doesn't really matter as long as you keep accuracy. So what was that decimal again? Some of the rest of you are getting on your head. I will tell you, in my other class, I didn't use decimals, and they got 27/50, which is the same thing. All right, and so we still need to put the pi there, right? And then that's then dh/dt. All right, plus, now you're going to type this in. 1/3 pi times 0.9 squared. You're going to get another decimal, and we could write it as a decimal or fraction. Doesn't really matter. You never want to round, though, in the middle of a problem if you do get a decimal. Okay, so if you get like one of those decimals that just repeats forever, you definitely want to use the fraction form because you can round your final answer, but you cannot round in the middle, or you're going to lose a lot of accuracy. Is this one 0.27? I didn't do that in my head. I'm not that good. I just know that it was 27/100 in my other class. All right, dh/dt. So do you see what I mean? It's just 0.54 pi times my variable. These are like terms. So let's just go ahead and add these up. What's 0.54 plus 0.27? 0.81, right? So 0.81 pi dh/dt. We're not going to work 5, so you can cross it off. So my final answer is going to be dh/dt equals, and then just divide that. Now, when you divide by negative 0.81 pi, you got to make sure you divide by both things, the negative 0.81 and the pi. So maybe you divide parenthesis 0.81 pi, or you could just leave the pi out because you know it's going to be in the denominator. I'm curious to see what your answer is going to be, though, in your calculator if you use the decimals.
0.786.
And you didn't get pi in your in terms of your answer?
Oh, I didn't get it in terms of pi. Because
you had to round, right?
Yeah.
Okay. Did somebody plug in -2 divided by 0.81 and see what you get for that?
I got negative 2.46.
And it ended after the 6?
Oh no, 6914.
Okay. How do you go? So this is our final answer, so it really wouldn't be that big of a deal if we multiplied the pi out, divided the pi out, or whatever. But do y'all remember how to go from a decimal to a fraction?
Yes.
Well, diamond inner is how we approximate. Does that work the other way? So what about if you're in your F2 algebra screen? You can get your exact. That's not it. So I don't want to write a big long decimal here. I'm feeling a little like I don't want to write that. So here's what I would like for y'all to do. I want y'all to type in -2 divided by 81/100ths. And then we're dividing by pi, so pi is going to be on the bottom. So I want to see what you get with this. Or maybe use this part, you can probably do it in your head. -2 divided by 81/100ths. Yeah. And our units here are going to be feet per, was it minute or second? Minute. Okay, so does it make sense that my answer is negative?
yeah.
Yes.
Why does that make sense? The height is decreasing as the water is pouring out. Okay? If in the beginning you had left out the negative with V, that could have caused this answer then to be positive, and so you could catch it either way. Always check the reasonableness of your answer. All right, and if you have the decimal here, that's fine. I really, if your final answer is accurate to 3 decimal places, you're good. Okay, regardless of what it looks like. All right, what I want to do now is go and look on the next page. And this also, we're not going to get through all of this today, but we're definitely going to get through kite problems. And I think we're going to even get to a ladder problem. The shadows are going to have to wait. That's okay. These problems, really, you have all the knowledge to do them, but they all kind of have little things that pop up that are just slightly different. We're not using a different strategy. We're going to use the same strategy. So when you look at this problem, one thing that I'm going to tell you is drawing a picture makes this way easier. The reason is before cones, spheres, circles, there wasn't a whole lot to the picture. We saw the picture with the cone was beneficial. But here with the kite problem, you're always going to want to draw a picture. And with kites, you're always going to draw a right triangle. Because what you're going to have is a vertical distance, a horizontal distance, and then the actual kite string. So here's your kite, and then here you are right here, flying your kite. Okay, where the hypotenuse is the kite string. So I'm going to label the 3 sides of this triangle, here we go, as C, B, and A. What does that make you think of? Pythagorean theorem. That's going to come up. Okay. I'm always going to label the height A because A stands for altitude. It makes it really easy. Also, B stands for base. I think it makes it easier to see. And C is always going to be the hypotenuse, which is going to be your kite string in kite problems. Okay. So I'm going to read through the problem, and I want you to see if you can label anything on the picture. All right. So a kite is moving horizontally with a speed of 7 meters per second at an altitude of 30 meters. Determine how fast the length of the string is increasing when the kite is 50 meters from the kite flyer. Now, if you're looking at that saying, I don't know how to do that, you're right. You can't read that and say, the answer is blah. You can't do that. You got to just go through it. So, were there any sides of the triangle that they gave us? They gave us A, right? What's A? 30 meters. And they gave you that this is like our when statement when the kite is 50 meters from the kite flyer. Now, if they don't say 50 meters vertically or 50 meters horizontally, what they're talking about is the length of the actual string. Okay, like truly, how far is the kite from the person? So some students like to think that's the ground distance. They'll say, how far horizontally, or what's the ground distance, if that's what they mean. All right, and then we did get, before I go to that next one, do you know what the third side is? How do you know that? You guys are quick.
It's a 3, 4, 5 triangle.
Yeah, it's a 3, 4, 5 triangle, and that's one of the best things about calculus is when you have these right triangles, they're almost always going to be triples. And they're typically going to be 3, 4, 5, or 5, 12, 13. They're not going to be those weird triples that you had to know if you ever took pre-AP geometry. All right, and this right here, what is this telling us? The speed of what? So it's giving us d something over dt. Which one? dB. B is a horizontal, so they're saying, okay, dB over dt is equal to 7 meters per second. Right? Which one are they asking us to find? How fast is the length of the string?
DC.
Yeah, they want to know what is dc over dt.
Where did that B come from?
We did Pythagorean theorem. Since the hypotenuse was 50 and one side was 30, the other side has to be 40. You could go and do Pythagorean theorem to find that third side.
So like, where did the
Oh, dV over dt. This says, first of all, speed is the same as rate, which means derivative. Derivative of what? Horizontal had to be dV over dt. Good question. All right, so once you've drawn the picture and wrote out all your information, you really don't need Fuigi, but I'm going to do this anyway. because I like the order, and I like that I'm going to reverse the order when I actually go through the problem. Because otherwise, you may not even really know where to start. So what are we trying to find? We wrote it over here. Yeah. dc over dt. The when and the given, I'm actually not going to write these down because all of that's on my picture. You can write it down again if you want, like when the kite is 50, when c equals 50, and then you could write everything there. But I've already written it down on the picture, so I don't really need to write that down again. And you guys already told me, but what's the equation we're going to use? Pythagorean theorem. A squared plus b squared equals c squared. Okay, so that's what we start with. Okay, we're going to take the derivative, d over dt, of a squared plus b squared, and we're going to take the derivative of the right side, which would be c squared. Okay, on every kite problem, this is what you're going to do. So when you see kite, you need to think, draw the picture, Pythagorean theorem. Okay, so now we got to take the derivative. What's the derivative of a squared? 2a. 2a. A is not the same as t, so I got to write dA over dt. Okay, plus, what's next? 2b dB over dt, and then you got the hang of it now. 2c dC over dt. Which one of these am I trying to find again? dC over dt. So I'm going to circle it, and I'm going to go through and see what else. I should know everything else. Okay, so the 2 I got. What's A? A is 30. Just look at your picture. dA over dt. They don't give it to us. So that means it must be really obvious, or more likely, it's a 0. That's just a typical rule of thumb. So let's think about this. You're flying a kite, and the string's going out, and they tell you your horizontal speed, and they tell you the altitude. Do they say anything about your altitude changing? Yeah. If they say your altitude is this, and they don't say anything about your altitude changing after that, then your dA over dt is 0, because this 30 meters is not changing in this problem. If you have to assume, you never want to assume something's happening that's not. Really, you just assume nothing's happening. This, miraculously, whatever's happening with the wind and the kite, this kite is going to stay exactly at the same altitude. Well, that's unrealistic, but, whatever, okay? We're going to deal with one in a minute where the altitude is changing, and you'll see what that looks like. All right, plus 2. Our b value is 30. dB over dt, they did give to us as 7, equals 2. Our c value is 50. And let's see if I can squeeze this in. dC over dt. Okay, so now I have an equation, and I have all numbers except for what I'm trying to look for. So I want you to use your good algebra skills and your calculator to solve out dC over dt. Do whatever you need to do, however many steps you need.
Do you need it in decimal form or fraction form?
As long as it's accurate, it doesn't matter whether your answer is a decimal or a fraction. Yeah, on this one, it won't be a whole number.
Yeah, I got a fraction.
So if you're not sure what you're supposed to be doing right now, this is going away because it's 0. You could multiply these numbers and then maybe divide. This is going to be 100 over here, so maybe divide by 100. What's the answer?
28 over 5.
So I got 28 over 5. That's going to be in meters per second. Anybody get the decimal? 5.6. So either answer would be fine, but you do need meters per second either way you do it. All right, so let's make sure this makes sense. My answer is positive. Does it make sense that if I'm letting out the string, which is what they say, okay, the string is increasing, does it make sense that dc over dt is positive? Yes. You always want to check this. This is the best way you can check for mistakes. It won't catch all mistakes, but it'll catch a lot of them. Okay, now, I want you to read through number 2, and I want you to find the only piece of information that's different than number 1. Everything's the same except one piece of information. I want you to find it. When you find it, I want you to write it down. You can kind of stop at the first sentence, right? So falling vertically with the speed of 5 meters per second. Which side was our vertical side? A. So this is giving us what? dA over dt, and that's equal to -5. That negative part's important. What's our key word that we knew it was even going to be negative?
Falling.
Falling. That's negative. Okay, so what you're going to do is you're going to recalculate your answer. Now remember when we put 0 in? Don't put 0 in. Put -5 in. And recalculate. When you get your answer, I want you to think, does this make sense, positive or negative? And your answer is going to be either higher or lower than it was before, and I want you to think, does that make sense? See if my memory serves me for my other classes. Did you get 5 over 4? I'm not just remembering. What'd you get? 13 over 5. Oh, I think I just gave you the answer to another problem. That's okay. All right, 13 over 5. So this is obviously, and this is 2.6, by the way, as a decimal. That's what you got. But this is obviously positive. That still makes sense, just for the same reason in the last one. But I decreased, right? So my string is going out still, but at a slower rate. Does this make sense with the fact that somehow the wind is pushing this kite down? Okay? If the kite is lower to the ground, you don't have as far to go. You don't have as big, it's not, the hypotenuse is always the longest side. But as one side gets shorter, the hypotenuse is getting closer and closer to your horizontal distance.
You can even use the equation like c squared equals a squared plus b squared, if a is decreasing and c is also increasing.
That's right. Exactly. If one of the sides is decreasing, c is increasing, and vice versa. Now, if the two sides, one's increasing, one's decreasing, it's not as obvious. But we don't typically have those problems, so that's good. All right. Let's look at 2. We're going to look at this ladder problem, see how far we get in it. Probably won't do all the parts. That's okay. So we have this 13-foot ladder. What type of picture? I mean, think back to geometry. When you saw a ladder that's propped up against a building, a right triangle again. So this is really going to work just very similarly to the kite problem. So they tell us that the ladder, which is the hypotenuse, right, is 13 feet. It says when the base of the ladder is 5 feet from the base of the house, so B is 5 feet, it's moving with a velocity of 3 feet. So it here, you know, we don't really like to use the word it, but if it comes in a sentence, you can sort of imply, but I still don't like that word. But it's talking about this horizontal distance right here. So dB over dt. Remember, all rates are going to be derivatives. And if you're not sure if something's a rate, just look at the units. Feet, that's not a rate. Feet per second, that's for sure a rate.
This could be a positive 3.
So it is going away, but is the distance increasing or decreasing? That is tricky, right? The distance is increasing, so the rate is still positive, even though we're moving away. That could be tricky. But I will tell you, at the end, if you made that mistake at the end, your answer wouldn't make sense. So we have that. Do we know anything else based off of the situation?
Yeah.
A is definitely 12 because this is our other triple that we know really well. And they want to know how fast the top of the ladder is moving. So basically the ladder is going down. What we're trying to find is dA over dt. Do you think the answer is going to be positive or negative? Negative. Okay, go ahead and even write it. If we continue the Fuigi, we can just say that comes from the picture. The equation we know is going to be a squared plus b squared equals c squared. And again, we're just going to take the derivative. Now, we've already taken the derivative of Pythagorean theorem. You're just going to get the same result. Okay, so that's good to know. When you do d over dt to both sides, you're still going to get 2a dA over dt plus 2b. And then this is where things start getting easier because you've seen this before. And I said easier. It doesn't mean it's easy, but it gets easier. All right, I want you to go ahead and fill in as much as you can of that and see if it's enough, or maybe we need to find something else. Yeah, we don't know, or they don't tell us dc over dt. Now, what did I say that usually means? It's usually 0, or it's so obvious, like we should know it for some reason, okay? And, you know, it's usually going to be 0. And dc over dt is 0. How do we know that? For sure. So the ladder's moving, but is the ladder getting longer? No, never. So there is no rate of change on the ladder. It's not getting longer, it's not getting shorter. We're not going to even pretend like this is an extendable ladder. That's a whole bigger mess of a problem. So we can plug in a 0 over there, which we know makes the problem easier because then I just have 0 on the whole right side. So I want you to go ahead and use your good algebra skills to isolate dA over dt.
This was the problem.
This was the answer. I'll leave
Yeah.
it for you. Okay, you should have gotten negative 5 over 4 or negative 1.25 if you were doing decimals. And negative makes sense here. We already said, we predicted our answer was going to be negative. Okay, we're just going to do the area really fast. Okay, and then we're going to call it quits for today. Oh, sure. Okay, so determine the rate at which the area under the ladder is changing. So what are they asking us to find here?
Derivative of the area?
Derivative of the area. Now, I haven't talked about area yet. Your win, your G, still this is going to come from the picture. But what's my equation now? 1/2 base times height, because we're talking about a triangle. Okay? Eventually, what will the area become as this ladder slides? 0. Okay, but in the meantime, do you think it's going to increase or decrease? It's got to decrease, right? So my answer is going to be negative on this one as well. Area, I'm going to actually write it as 1/2 base times A, because those are the variables that I have in the problem. So let's take the derivative. Derivative of A, derivative of TBA, or I don't know why I said that's weird. 1/2 BA, and B and A are both variables, so what am I going to have to do? Product rule. You thought you were going to get away without having to do product rule again today, right? Okay, so derivative of 1/2 B. Well, that's just 1/2, and since I took the derivative of B, I've got to write it. Then you just write A. Plus, then you just write 1/2 B, and you take the derivative of A, which would be dA over dt. Okay, what I'm considering here is that 1/2 B is the first and A is the second. Now I know dA over dt. Now I can do this problem, but if this had been first, I would have had to do this whole, part A would have been like a whole side problem. All right, so it's kind of nice that they came in order. So dA over dt, it's going to be 1/2 3. A was 12, yeah, plus 1/2 5, and then now we have our answer over here. So let's plug it in and see what we get.